Hello again and welcome back. Here it is. We're going to talk about reciprocal functions today. So let's get into it right away. So let's start considering linear equation, the very famous one, the mother function y equal to x. They call them parent function, but I think I can call it mother function. But anyways, that's a parent function y equal to x. That's a line. There's basically at 45 degrees crossing the origin. Now, the reciprocal function is when you have this function is 1 over the original linear function, 1 over x. Now, I gave you the very basic reciprocal function, but reciprocal functions do not have to be the reciprocal of a linear function. They could be quadratic, could be cubic, and there are many forms of reciprocal functions, but this is one form. The only thing that all of them have in common is that there must have 1 on top. Now, this is a subset of what we call a rational function. So reciprocal functions are a subset of a rational function. And now, once we have this, notice that x cannot be 0 because 1 over 0, that is not defined. So that is one of the key characteristics of reciprocal function. And what we say is that there are restrictions or non-permissible values, depending on what language you're used to, for values of x, and then we can find that for some values of y. All right, now let me give you some examples of reciprocal functions. So starting with very simple one, this is example of reciprocal functions. Y equals to 1 over x squared plus 1. That's a reciprocal function. Okay, next one, y equals to 1 over x minus 1. That's a reciprocal function. Another one, y equals to 1 over x cubed. That's a reciprocal function. All right, and so forth and so on. Now, let me give you another one, 1 over x squared plus 4x minus 2. That's a reciprocal function, okay? So you could have many types of reciprocal function, and doesn't matter which way you look at it, as long as it has a form of 1 over the original parent function, whatever that is. All right, so these are the examples of reciprocal function. Now let's go ahead now graph the original function, the linear function. We're going to start with a very basic one. Linear equation, we're going to graph this line, and then we're going to graph the reciprocal of that line. That becomes a reciprocal function. And then let's see what we can come up with and list all the characteristics of a reciprocal function. Okay, now that we have got the table set up, I want you to focus on x1 right now and y1 and ignore x2 right now. So y1 and x1 is the equation that we're going to draw. We're going to graph the equation of the line, and that is y1 equal to x1. That's y equal to x, okay? And Desmos is giving you the y1 and x1 just because of we have another function that comes in. Now, these are the table of values, and we know how to graph these. That's very simple, a line. So I'm going to click in y1, and you notice that there are plotting points right there for every each value of x1. You have a same value for y, and then you draw a line right through that, okay? So that's a straight line, and you've done this many times. Now, look what happens when we are using the reciprocal. So here is 5 became 1 over 5 for the new function, okay? Okay, now look at what happens to the y function, the new y function, when we do a reciprocal. Remember, every time that we have an original function, we put it under 1, so 1 over, and every number that you have for x for the input has to be basically put under 1. And when you do this, when you graph this, and notice that all of these values, corresponding values, have been reciprocal or flipped by 1 over 1. And then you get this curve, one in quadrant 1 area, the other one is quadrant 3 area. And I chose only 10 or 15 points in here, but you could just continuously plot points and you get many, many points. And you can graph it as accurately as you can. But this is not a line anymore. This is a curve. So a reciprocal function usually, not all the time, usually is a curve, and it's a discontinuous graph. So one of the characteristics of reciprocal function could be that's a discontinuous graph. Not always, but oftentimes. Now, few things. Notice that this graph is coming closer and closer and closer to the x and y axes, but will never ever cross it. Remember the restrictions. I can't put in x equal to 1. Like if I, sorry, x equal to 0. Look what happens if I put 0 in there. It will not plot that because it doesn't know what to do. It's undefined, right? So neither x nor y could be 0. X cannot be 0 because 1 over 0 doesn't exist. We don't know what that is. And because of this cannot be 0, therefore y cannot be 0. All right, now let's go back to the notes and try to put in a few terminologies because they are very, very important. Notice that this point right here, 1, 1, and this point right there, -1, -1, these 2 points are very crucial points where the curvature starts changing. In reciprocal functions, we call these 2 points invariant points because they will not change, because 1 over 1 is 1, so that's not going to change, and so is -1. So let's go back to the notes and put them all in the notes. All right, so we graph y equal to x, then we graph y equal to 1 over x. We said that x cannot be 0. That's one of the restrictions, and it's right here. Now let's list all the characteristics of reciprocal functions. The first thing, x cannot be 0. The next thing is y also cannot be 0 in this context. Okay, that's another one. Now, because x cannot be 0 and y cannot be 0, there are these 2 vertical and horizontal boundaries. So vertical and horizontal lines, they're almost like invisible lines, but there are boundaries that the graph, the function, doesn't cross. We call those lines asymptotes right here. We have, now look at the graph now. So it's the same graph that I just showed you through Desmos. I just plotting a few other points so they can see. So the vertical line, I put it in the red dotted line, that the vertical line, that's a vertical asymptote, and it has an equation. The equation of this vertical asymptote is x equal to 0. All right. Now, because it also has the horizontal boundary line, there's a horizontal asymptote, and the equation of this line, the horizontal line, is y equal to 0. This is one of the characteristics of reciprocal functions, that they could have asymptotes, vertical and horizontal, or just vertical, okay, or just horizontal, okay. All right, now remember the invariant point. So this is the invariant point, 1, 1, -1, -1, because it doesn't change. All right, so it is a curvature. It is also what by definition is a discontinuous function. Sometimes, for the most part, it is, but there are exceptions, by the way. I have to make sure, okay? Reciprocal functions, sometimes, for example, 1 over x squared, that is not a discontinuous function. Okay, so those are the 3 major characteristics of reciprocal functions, and especially the 1 over x, because we call this a parent function for reciprocal functions, and after this we can add many more. If you found this useful, please consider subscribing, like the video, and make comments below, and let me know what topics or specifically lessons you want me to go over, so that when I post a new video, you get notified and you can actually review your material as well. All right, be well, until next time.